simplify the following rational expression, where you have x plus 2 to the fourth power times x squared, x squared plus 6x plus 9 cubed all over x squared plus 5x plus 6 to the fifth power. Now, before you start multiplying all these out, you have to notice a little bit of a trick. And the trick is to notice that x squared plus 6x plus 9 factors into x plus 3 times x plus 3. So this becomes x plus 3 squared. And similarly, x squared plus 5x plus 6 also factors into x plus 3 times x plus 2. So what we can do is, where you see these trinomials, you can substitute them for their factored value. So now let's rewrite it using the substitution. So x plus 2 to the fourth power stays the same, and then here you have x squared plus 6x plus 9, which we know is x plus 3 squared, but that's all taken to the third power. And then in the denominator we have x plus 3 times x plus 2, which is all taken to the fifth power. So now, in order to simplify, we have to recall a couple of laws of exponents, right? So the first law to recall is in this numerator here, where you have a power taken to another power. What you do with the exponents is that you multiply them. So a to the r to the s is going to become to a to the r times s. So in the numerator, x plus 2 to the fourth stays the same, but here we're going to get x plus 3 squared to the third power. So you can think of it the same way as this. So multiplying the exponents, we have x plus 3 to the 6. And then for the denominator, you can think of this as the exponent rule, where you have a times b to a certain power r. What happens is that exponent distributes over the product. So this becomes a to the r times b to the r. So in the denominator, we're going to be getting x plus 3 to the fifth power times x plus 2 to the fifth power. So now we are not quite done, because notice that there's, let me use blue, light blue here. So there's an x plus 3 in the numerator and the denominator here, right? And there's also an x plus 2 in the numerator and the denominator here. Those are terrible sort of circles, but you get the idea, right? So the last thing to use is the property of exponents that says that if you have a number taken to one power, and then you have that same value taken to a different power, what you do is you subtract the exponents. So in this case, we can subtract the exponents for the x plus 3 value and for the x plus 2 value. So rewriting this becomes x plus 2, and then subtracting the exponents, we have 4 minus 5, and then x plus 3, we get 6 minus 5. Right? And doing these simple additions, we get x plus 2 to the negative 1 power, and then x plus 3 to the 1 power. And then the last thing to do is, we generally don't like leaving negative exponents. So what you do when you have a negative exponent is that negative, it just gives you the reciprocal, right? So we want to take the reciprocal of this, which is just going to be 1 over x plus 2 to the 1 power. So just 1 over x plus 2. So this is going to give us, let me go down here, 1 over x plus 2 times x plus 3, and then finally putting it together, we get x plus 3 over x plus 2. And since there's nothing else we can do to simplify, this is the final simplified form.